Hello, welcome. My name is Sir Kofi. I am a student of planning and GIS, and on this channel, I talk about how to do mapping with ArcGIS, QGIS, and ArcGIS Pro. So if you are interested in this topic, kindly subscribe to this channel, hit on the bell icon, and like this video. Thank you very much. Okay, so in today's video, we are going to learn how to create land surface temperature with Landsat 7. This is actually a part 2 or a second approach. The first approach, that is the link up there. In that video, I went through 6 steps, but in this particular video, we are going to go through just 1 or 2 steps, very simple. In that video too, we used the band 6, band 4, and band 3, but here we are going to use the band 6. I actually call this particular approach as an outdated or incomplete approach, because if you watch that video I am talking about, the first one, you see that this particular video we are going to miss some critical steps, because aside the Landsat 7, even with the Landsat 8, 9, when you are calculating for land surface temperature, I also have videos on them, you can check them out. You go through 6 steps. You first have to calculate for the TOA. Then after that, you calculate for BT, brightness temperature. Then you calculate for NDVI. Do you get it? You calculate for the NDVI, and you use the NDVI to calculate for PV, proportion of vegetation. Then you use the proportion of vegetation to actually calculate for the emissivity. And with the emissivity and the BT, you come up with the land surface temperature. But in this video, we will end at the BT and call it land surface temperature. But the whole thing is that brightness temperature, BT, actually assumes a complete dark surface. Do you get it? And to get a correct land surface temperature, you need to apply emissivity to it. That is why I see this as incomplete. But then I still think I need to do this video, because it will serve as a learning point for us. We can all learn from it by comparing this video to the other one. And who knows, this one can also work for you depending on the conditions of the data you get at your location. And since this one is also a simple step, you can still like this over the other one. Do you get it? You might want this simple step over the other one that goes through. Yes, do you get it? That is why I think I still have to do this video. So having said that, let's get straight to business. So this is what we are going to do. The first step, we are going to convert the band 6 to radians. Do you get it? And this is the formula: L max minus L mean over kcal max minus kcal mean times this. Do you get it? And we will get all those things over here. Are you getting me? Okay, so let's go back to ArcGIS. You go to the Arc toolbox, then you go to the Spatial Analyst tool, then you go to Map Algebra, Raster Calculator. Do you get it? So when you get to the raster calculator, the first step in the step, we have the L max, which is what? Radians maximum band 6. The radians maximum band 6 minus radians minimum band 6. So you open a bracket over here. The brackets should be double. Then you go to the MLT text. Do you get it? If you've been watching the land surface temperature, you see that there is always MLT text attached. So you open the MLT text and you find some information in there. Radians maximum, radians add band. This is radians add band. Radians maximum band 6. This is it. So it is 255. So you have you seen it? No, this is quantized maximum. This is radians multiplicative. Radians maximum band 1, radians maximum band 6, and I am using the VCID band 1, VCID 1. Do you get it? So with the band 6, if you watched the previous video, I said that we have VCID 1, VCID 2. Do you get it? And I'm using the VCID 1 of the band 6. Do you get it? So when you go there, know the type of band 6 you are using. So the radians maximum VCID band 1. I'm not using the band 2, so I will copy the one which is with the VCID 1. Then I'll come and paste it here. Minus radians minimum it is 0.00, but let me still copy it and come and paste it here. And the formula is saying divided by. Are you getting it? So you come here, you have to close the bracket, then you divide it. Do you get it? By kilcal max. What is it? Quantize cal max band 6. Where is it? This is the quantize cal band 6. We are using the VCID1, so you copy that. If VCID2 is favorable to your location and you are using it, then you come and copy this. So I'm copying the one which is associated with VCID1. So it will be, you open another bracket here, this one minus quantize cal minimum band 6. So you go there, this is it, band 6 VCID1, it is 1. Quantize cal min band 6 VCID1, you copy that one, you close the brackets double. Are you getting it? Then the formula is saying we will have multiply by kilcal minus kilcal minimum. Do you get it? What is that? Multiply by this particular kilcal is the band 6 we are using. So the band 6 is here minus what? Minus kilcal minimum. This kilcal minimum of band 6, which is here, and that one is what? It is the 0 here, 0.00. Are you getting it? Quantize cal, no. So the kilcal minimum over here, which is quantize cal minimum of band 6. So the kilcal minimum over here, quantize cal minimum band 6. Quantize cal minimum band 6 is 1. Do you get it? So you come here instead of this, then you write the 1. You close the brackets. Are you getting it? So this is what we are having. Then you close the brackets again. Then you write plus. I'm using the plus sign here. L mean. So the 0 that I mistakenly wrote over there will actually come here. This one will be repeated here. This one will be repeated here. Are you getting it? So depending on your band, some band will not have the 0, 0. Do you get it? So depending on your band, it will determine the figures. Are you getting it? So when you are done, you can just copy it. This is the step 1. Then you press OK. So you are done calculating the radiance. So you can just hover the mouse pointer on it, then you write radiance. Do you get it? So when you are done, the second step is that we need to convert the radiance to BT. Do you get it? The BT I was talking about. And the BT is going to be K2 divided by ln K1 divided by this. Do you get it? So this is what we are going to do. What is the K2? The K2, when you come to the MLT text file, you see the K2 over here. K2 constant VCID1, K2 constant VCID2. So I'll copy K2 constant VCID1 because that is the band I am using. And I'll come back here and paste it over here. Divided by K1 constant, but before that, there is a conditional ln over here. This is the ln. Do you get it? ln in brackets K1. So K1 constant of VCID1, you copy it. That one divided by ln, L1. And that particular L1 is the radiance we calculated in the first step. So divided by the radiance. Are you getting it? Then you will see plus 1 over here. Have you gotten it? Then you write plus 1. That is it. So you can press OK. So the BT is here. So you can just write BT. Do you get it? So after the BT, what this formula does is that it will just subtract 273.5 from the BT and refer to the remaining answer as the land surface temperature. So for the last time, or with the last formula, we are going to go back and just BT minus this and run it. So according to this approach, this is our final LST. Do you get it? So I can just go here, choose this. Do you get it? So we've ended at the BT, just subtracted that figure from it to get the LST. But in the previous videos, after BT, we calculate the NDVI, we calculate the PV, we use it to calculate the emissivity before we use the BT to calculate the LST. Are you getting it? So this approach is very simple. You don't go through series of steps, but like I said, it misses critical steps. So we can just go the study area I've been using. I can just bring it here. Then I'll just clip it. So let me uncheck all these. Then go to the layout view and have this. LST. So you can see that the highest value is 40, the lowest value is 25. Yeah, I think in the previous video, the first approach, I think I got similar figures. Yeah, I think the highest was 40 because I'm using the same year, 2010. That same data I used for that approach, that is the same data I have used for this. And I think the highest figure was around 40, the lowest was around this. So even though the formula is simple, but then the figures are actually close. Are you getting it? But like I said, this one misses critical steps. So you can still decide on which one you will use. Are you getting it? But it is very good to actually know the reasons behind it, especially if you are a student, a researcher, so that you can defend it better. So you can go to the properties, stretch, divide it into 3, choose this, then we have this. Are you getting it? Yes. So that is it. Land surface temperature map for Landsat 7 using the incomplete or outdated approach. Yes. So thank you very much for watching, and I would like to see you in my next video. Bye bye.